In this video, we're going to look at the graphs of y equals cos x and y equals sin x by thinking about a unit circle. They're pretty similar graphs, so we'll spend most of our time looking at the cos graph and then move on to the sine graph at the end. Let's start off by thinking about what a graph of y equals cos x would look like. Recall from the unit circle that cos is the first coordinate of the point at the circle's edge. So for instance, here you can see that cos 35 degrees is about 0.819. From thinking about the unit circle, you can see that cos of any angle is between -1 and 1, so the y-axis doesn't need to be very big. The x-axis needs to at least have space for angles from 0 to 360 degrees, so we'll make that nice and big. Let's work out a few points that go on the graph. If we have an angle of 0 degrees, we can see that cos 0 degrees equals 1. So let's plot 0, 1 on our graph. If we move the angle to 90 degrees, the cos value is 0, so that gives the point 90, 0. Moving through the second quadrant to 180 degrees gives us cos 180 degrees equals -1, so we can plot 180, -1. Down at 270 degrees, we can see that cos 270 degrees equals 0, giving the point 270, 0. And finally, moving through the fourth quadrant to 360 degrees tells us that cos 360 degrees equals 1, so we can plot the point 360, 1. We're back to the start, so going around the circle again we'll repeat the cos values. For instance, at 450 degrees we get 0 again, and at 540 degrees we get -1 again. We could also go into negative angles and see what happens. Going down to -90 degrees, the cos value is 0, so we get the point -90, 0. And going back to -180 degrees, we get -180, -1. From the points we've plotted, you might think that the cos graph consisted of straight lines in a zigzag pattern passing through these points. But there is no reason to believe that these sections of graph should be straight. If we have a straight line from 0, 1 to 90, 0, then it would pass through 45, a half. That would mean that cos 45 degrees equals a half. But cos 45 degrees isn't a half. Look at the isosceles triangle it makes in the unit circle. The hypotenuse of the triangle is 1 because that's the radius of the circle. The cos value is a, and so we get a squared plus b squared equals 1. But a equals b, so a squared plus a squared equals 1. So a equals 1 on root 2, or about 0.707. This means the actual point is 45, 0.707, so the graph can't just form a zigzag of straight lines. We can work out the coordinates of other points on this graph using a calculator and plotting them as we go. You can see that these are going to form a curve, so let's join them up with a smooth curve, which gives us our graph of y equals cos x. Now that we have a graph of cos x, we can notice a few things. Firstly, it repeats itself after 360 degrees. It started at 0, 1, then reached the top point again at 360, 1, once we've gone around the circle once. It will keep on repeating every 360 degrees, because whenever you go around the circle, you're back at the same point again. Let's zoom out a little, so we can see a few complete cycles of the graph. You can see there are 3 cycles here, from 0 to 360 degrees, from 360 to 720, and from 720 to 1080. The graph also repeats into the negative angles, so let's include a cycle going to -360 degrees. Because the graph repeats every 360 degrees, we say that it has a period of 360 degrees. You might think that the period would always be 360 degrees, but if you change the rule slightly to something like y equals cos x on 2, the graph is stretched by a factor of 2 horizontally, so the period is now 720 degrees. Or if you had y equals cos 3x, the original graph is squashed to a third of its width, so the period is now 120 degrees. Even if a cos graph is translated up, down, left or right, it will still have a period. For instance, the graph of y equals cos 3 x minus 45 minus 0.5 has been shifted right 45 and down 0.5 units. But the period is still 120 degrees. The only thing that affects the period is how much the graph is dilated horizontally. So even if you imagine a general cos graph as having a rule like y equals a times cos b x plus c, all plus d, the only thing affecting the period is the b value. The period is 360 degrees divided by b. Going back to the original graph of y equals cos x, you can see the y values are all between -1 and 1. So we say that the amplitude is 1. Now let's stretch this graph vertically by graphing y equals 2 cos x. Now the y values are between -2 and 2, so the amplitude of this graph is 2. The amplitude tells you how much the cos graph is stretched vertically. So even if you shift the graph up, like with y equals 2 cos x plus 5, the amplitude is still 2. The maximum height is 7 and the minimum is 3. So if you wanted a formula for amplitude, you could think of it as half of the distance between the maximum and the minimum heights. If the general rule for a cos graph is y equals a times cos b x plus c all plus d, then the amplitude is determined just by a. If a is positive, then the amplitude is a. But if it's negative, then the amplitude is negative of a. For instance, let's look at y equals -½ cos x plus 1. The graph is flipped upside down, halved in height, and then shifted up 1 unit, so the amplitude is a half. The graph of y equals sin x is very similar to the graph of y equals cos x, so I'm going to go through that a bit faster. On a unit circle, the sine of any angle x is the second coordinate. So, sine of 0 degrees is 0. Sine of 90 degrees is 1. Sine of 180 degrees is 0. Sine of 270 degrees is -1. And sine of 360 degrees is 0. Joining all these points up with a smooth curve, we get y equals sin x. Like the cos graph, this graph has a period of 360 degrees and an amplitude of 1. The period will change when you stretch the graph horizontally. And the amplitude will change when you stretch the graph vertically. Let's summarize the main points of this video. The basic graph of y equals cos x starts at 0,1. It goes down and then back up again before repeating every 360 degrees. The basic graph of y equals sin x starts at 0, 0. It goes up and then back down again and then up before repeating every 360 degrees. The period refers to how long before the graph repeats. The amplitude is half the distance between the biggest and smallest y values. The general form of these graphs is y equals a cos bx plus c all plus d and y equals a sin bx plus c all plus d. And from these you can get the period and the amplitude. There's lots more you can do with cos and sine graphs, but this video should help you understand the basics.